So let's have a look at question 18. Here it says, Daryl wishes to save money to provide for his retirement. Beginning 1 month from now, he will begin depositing a fixed amount into a retirement savings account that will earn 12% compounded monthly. He'll make 360 such deposits. Then 1 year after making his final deposit, he will withdraw $100,000 annually for 25 years. The fund will continue to earn 12% compounded monthly. How much should the monthly deposits be for his retirement plan? Now, whenever we're dealing with a word problem that involves time value of money calculations and you find yourself to be stuck, one tip that I could offer is to begin by setting up a timeline. Help yourself visualize the cash flows that are sort of involved. So with this question, we're going to do precisely that. The first thing I'm going to do is simply set up a timeline so that I can organize all the information. My timeline is going to start from time 0 and going to extend until time 360. And that's simply because there are 360 monthly deposits that are going to be made in this account that is earning 12% compounded monthly as well. So from time 0 until time 360, which is essentially the same as 30 years, there's a fixed amount that is going to be deposited into this account. We don't know what the amount is, so I'm simply going to say it's X dollars every month. If I continue to read, it tells me that 1 year after making his final deposit, he's going to be withdrawing $100,000 annually for 25 years. So a year after time 30, up until time 55, there's going to be annual withdrawals of $100,000 a month, or rather a year, and that's because it's 25 years. And now the question is simply asking us to figure out what is the value of X. How much do we need to deposit each month for the next 30 years so that we can sort of sustain these withdrawals? So now that we've sort of set up a timeline and we've visualized the cash flows, the next step is going to be to figure out how much money do we actually need. Try to understand that both streams of cash flows that we're dealing with represent annuity cash flows. Why are these annuities? Well, simply because they're the same amount, they're being repeated over equal blocks of time, and they're being offered for a certain or fixed amount of time. And so whenever we're dealing with an annuity, the feature on our finance calculator that would be useful is essentially the payment button. With this logic, let's move on to the next step. The next step is really to figure out how much money do we need. Essentially, we're going to figure out what is the value of these annual withdrawals at time 30. So in step 2, we're essentially going to figure out what is the value of these 100,000 annual withdrawals at time 30. And now the way that we're going to do that is simply by using our finance calculators. On our finance calculators, we're going to set PY to 1. The reason why PY should be 1 is simply because the timing of the payment is an annual payment. Since this 100,000 is being withdrawn each year, PY, or payments per year, should be set to 1. For CY, we're going to set the calculator to 12, simply because the interest rate that is offered to us is compounded monthly. For payment, we're going to put the dollar value of the payment, which happens to be 100,000. For N, we're going to put the number of years multiplied by PY. So since it's annual payments, N is simply going to be 25. The future value is going to be 0 because there's no lump sum amount that happens at the end of our timeline. The interest rate, or IY, is going to be set to 12% simply because that's the rate that has been quoted to us. And present value is what we're going to compute. So once we type these things into our finance calculators, the calculator is essentially going to take these 100,000s and figure out what they would be worth in one lump sum at time 30 rather than over 25 years. So let's have a look at the finance calculators and make that happen. I would always recommend to begin by pressing second FV. What that essentially does is that it clears the gray TVM buttons. I'm going to press 12 for IY, 25 for N, 100,000 for payment, 0 for future value. I can press second IY. I'm going to change PY to 1 simply because there's one payment per year. And I am sure to press 1 followed by enter, not equals. I hit the down arrow. For CY, we're going to press 12, enter. So PY is set to 1, CY is set to 12. I can press second compute to exit the worksheet. And I'm simply going to compute the present value. And the truth is I'm going to need this number later on. So I'm going to switch the sign to a positive by hitting the plus minus sign on the bottom right. And I'm simply going to press stow followed by 0 in order to save the number in the button 0. Or I can press stow 1 if I wanted. So now we have the present value at time 30 of these $100,000 withdrawals. So we know the amount of money that we would need to have in our account at time 30. Once we've done this, the next step is to sort of solve for these monthly payments, to solve for X. We know that in 30 years or after 360 months, we want our account to accumulate this amount of money, $748,642. So now we're going to try to figure out how much money do we need to set aside every month for 30 years or 360 months so that we can accumulate this amount. So once again, the way that we're going to do that is by using the help of our finance calculators. In our finance calculators, we're now going to set PY to 12 simply because we're saving money every month. CY is still going to be 12 simply because we have the same rate that is being quoted to us. So IY, the interest rate is also 12. For FV, we're going to put the answer that we got in the previous step. So 748,642.0556. Present value is going to be set to 0. N is going to be 360. It's the total number of payments, not the total number of years. It's really 30 times 12. There's 360 payments in total. And now payment is what we want to compute for. So once again, we're going to use the help of our finance calculator. We're going to enter these values and solve for payment, and hopefully that would help us answer this question. So the last value that I have on the screen is the amount that I computed in the prior step. I can simply set this as the future value. I can press 0 for present value, 12 for IY, 360 followed by N. I can press second IY. And now I'm going to change the PY to 12 because we're making monthly payments. And I'm going to keep CY also as 12. At this point, I can press second compute to exit the worksheet and simply press compute followed by payment in order to determine what the payment is. So I'm just going to double check the inputs to make sure that I put them properly. And so the answer that I'm getting for payment is 214.2059. So let's just check if that is in fact one of the responses. And so yes, if we round this to the closest cent, would go with answer C, or number 3. So I'm hoping that sort of answers your question. I hope that you understand what's happening. You're not just memorizing answers. Whenever you're dealing with a complicated TVM problem, one that involves more than one step, the first thing that I like to do, as I mentioned earlier, is really just to set up a timeline so I can visualize what's going on. And then whenever I recognize the pattern of cash flows, so here I know that I'm dealing with annuity cash flows, I am tempted to use my finance calculator. I know that an annuity involves payment. And so with the help of my finance calculator, I first determined the amount of money that I would need for my retirement by simply finding the present value of these $100,000 annual withdrawals. We knew that there are going to be 25 withdrawals of this amount, and we figured out that at time 30, they would amount to $748,642. Once I determined how much money I would need in my account at the end of 30 years, I'm now all set up to be able to figure out how much money I got to put aside each month so that I could achieve this retirement goal. One other tip that I want to offer is that whenever you've set up your timeline and you know that the missing value is on the left side of my timeline, I start bringing the cash flows from right to left. Had the unknown been on the right side or in the future, then I would be compounding cash flows instead. I would be moving the cash flows from left to right. I would be finding future values rather than present values. So I hope that helps and that it answers your question.